Time. It flows like a river, carrying us ever forward, never stopping, never slowing down. It is a force that shapes our lives, guiding us through the moments that define our existence. From the cradle to the grave, we experience its relentless march. Each stage of life, from the innocence of childhood to the wisdom of old age, is a testament to time's unyielding progression. But where does this river originate? What is the source of this unstoppable flow that governs our existence? And where does it ultimately lead? Is there an end to this journey, or does it continue beyond our understanding? These are questions that have captivated philosophers and scientists for millennia. The quest to understand time has driven countless minds to explore its mysteries. We mark time by the cycles of the sun and moon. These celestial bodies provide a rhythm to our days and nights, a natural clock that has guided humanity for ages. We measure it with clocks and calendars, tools that help us organize our lives and make sense of the passing days. But time itself remains an enigma. Despite our efforts to quantify and understand it, its true nature continues to elude us. It is a fundamental aspect of the universe, yet its true nature eludes us. It is woven into the very fabric of reality, influencing everything from the smallest particles to the vast expanses of space. Some believe time had a beginning, a moment when it all started with a cosmic event. Others argue it's eternal, stretching infinitely in both directions, with no beginning and no end. Our journey begins with the prevailing scientific theory, the Big Bang. This monumental event marks the start of time as we know it, setting the stage for the universe's grand unfolding. Around 13.8 billion years ago, our universe burst into existence in a fiery explosion of energy and matter, an event so monumental that it set the stage for everything we know today. This event, known as the Big Bang, marks the beginning of space and time as we know it, a singular moment that changed the course of existence. Before this moment, there was no before. Time itself began ticking from this point onward. Imagine an incredibly dense and hot point, smaller than an atom, yet containing the seeds of everything in the universe. This point, called a singularity, contained the potential for everything we see around us, from the smallest particles to the largest galaxies. Then, in a fraction of a second, it expanded rapidly, cooling and creating space as it went, a process known as cosmic inflation. As the universe expanded and cooled, stars and galaxies began to form, lighting up the cosmos with their brilliance. Planets, moons, and eventually life emerged, each step a testament to the incredible journey of our universe. The arrow of time, pointing from this initial moment of creation, dictates the direction of the universe's evolution, guiding the formation of complex structures and life itself. But is the Big Bang truly the beginning of everything? This question continues to intrigue scientists and philosophers alike. Or could there be something before? The mystery of what, if anything, preceded the Big Bang remains one of the greatest enigmas of our time. Some physicists propose a fascinating alternative, the cyclic universe. This model suggests that our universe is just one in an endless cycle of expansion and contraction. Imagine the universe expanding to a point where gravity pulls everything back together. This contraction, a big crunch, leads to another singularity, potentially sparking a new Big Bang. In this model, time has no beginning or end. It is a continuous loop, with each cycle potentially birthing a new universe. While intriguing, the cyclic model remains speculative, lacking concrete observational evidence. Could there be an even more radical explanation for the nature of time? Quantum cosmology delves into the realm of the very small to understand the very large. It seeks to bridge the gap between the minuscule quantum particles and the vast expanse of the cosmos. It grapples with the nature of space and time at the quantum level, where the rules of classical physics break down. Here, the familiar laws of Newton and Einstein no longer apply. Some theories suggest that before the Big Bang, the universe existed in a timeless state, a state where the concept of time as we know it had no meaning. Imagine a realm where time, as we understand it, simply didn't exist. No past, no future, just an eternal now. In this scenario, the Big Bang wasn't a beginning but a transition, a shift from a timeless existence to the dynamic universe we inhabit. This realm might be governed by quantum gravity, a theory yet to be fully understood. Quantum gravity attempts to unify general relativity with quantum mechanics. In this strange reality, time could be fluid, even irrelevant. While this remains speculative, it highlights the limitations of our current understanding of time. Our conventional notions of past, present and future might be mere illusions. But what about the end? If time is an illusion, does the universe have an end? Does the cosmic story have a final chapter? Or is it an endless cycle of transitions beyond our current comprehension?